Okay, so this is Calc Chapter 2, and 53, 54, 55 are all related to each other. So here's what we're going to do. We'll do 53 first, and then you have to use it in 54. When I get to 54, I'm going to do it a little differently. So 53 says, let's look at the limit as x goes to 0 of cos x minus 1 over x. And we're trying to show that that equals 0. Well, you can't just plug in the 0 or else you get cos 0 minus 1, which is 0, over 0, and that's not a determined form. So we need to manipulate this somehow. So we're going to multiply by a clever form of 1, which means let's try cos x plus 1. So when in doubt, let's try a conjugate, right? So then this is going to turn into the limit as x goes to 0 of cos squared x minus 1 all over x cos x plus 1. All right. Well, cos squared minus 1, you should remember sine squared plus cos squared, that equals 1. So then if I brought the 1 over, I get sine squared plus cos squared minus 1 equals 0. So cos squared minus 1 is negative sine squared. So this thing on top can turn into negative sine squared x over x cos x plus 1. All right. Well, let me rewrite this in a slightly longer form so you can see what you can pull out of this. So this is going to be negative sine x okay, negative sine x times sine x all over x parentheses cos x plus 1. And at this point, you can kind of, hopefully you see this. You've got a sine x over x. And so when x goes to 0, sine x over x, remember, turns into 1. So what we're left with now is the limit as x goes to 0 of negative 1 sine x over cos x plus 1. And at this point, you can actually plug in the zeros. We get negative sine 0 over cos 0 plus 1, which is 0 over 2, which is 0. Okay, so what we know now is that limit as x goes to 0 of cos x minus 1 over x, that equals 0. That's the conclusion from 53. So 54, what I want to do, actually, let's just do 54 the way it shows up. Show this is true. That's what we're trying to do. So I'll write that down here. I've got it memorized. So 54, limit as h goes to 0 of sine h, or t plus h, minus sine t all over h. Right here. So if we work this out, we've got limit as h goes to 0 of, limit as h goes to 0 of, let's see, oh, and then sine t plus h, that's the angle sum formula. So we're going to break that up. That's going to become sine t cos h minus, or no, sorry, plus cos t sine h. So that's the first term, and then there's still the minus sine t term, and then this is all over h. Okay. Whoop, sorry. All right, so let's go a little bit further with this. What can I do? I'm going to bring this sine t into the middle here. So limit as h goes to 0, sine t cos h minus sine t plus cos t sine h. And then each of these is really over h. I'm going to put the first two over its own h, and the second one's over its own h. But you could combine them to get back the original, the previous step. And the reason I split these up is for this reason. Right here, h is going to 0, and I've got a sine h over h. Well, that means that this part right here goes to 1. So then I'm just left with cos t. In the other side, so let me write this out. On the other part, I can factor out a sine t. And I'm left with cos h minus 1 all over h. And then plus the cos t times 1 that I have left over here. Okay, so at this point, let's see. At this point, I've got a cos h minus 1 over h as h goes to 0. Well, over here, I had a cos x minus 1 over x as x goes to 0. So really, this thing right here is of the same form as this right there. So that means that the highlighted part in blue here turns into 0, because that's what we said right here, turns into 0. So now what I can write is that this equals the limit as h goes to 0 of sine t times 0. Well, actually, I don't need the limit anymore because all the h's are gone. So it's sine t times 0 plus cos t, which is just cos t. And that was what we were trying to prove, that this limit equaled cos t. All right, so now we've got two conclusions. We've got this conclusion and we've got this conclusion here. So then there's one other part to 55 here. Find the slope of sine t at t equals pi and t equals 5 pi over 6. Okay, so 55. Find the slope, so f of t equals sine t, and we want the slope at t equals pi and t equals pi over 6. So two different places where we want the slope. Well, the slope, think about it. The slope at a specific point, we're going to do the h goes to 0, f of t plus h minus f of t over h, where t is pi and t is pi plus 6. Well, we already did it, because if I work this out in general form, that's going to be sine of t plus h minus sine of t all over h. That was number 54, which we just figured out was cos t. So the slope, so this thing right here is the slope of sine t at whatever t value you want, at t equals whatever, whatevs, right? So let's plug in our t's. So the slope at t equals pi is, so at t equals pi, the slope of sine t is going to be cos of pi, cos t, which is cos pi, which is -1. And at t equals pi over 6, the slope of sine t is going to be cos of pi. Is it pi over 6? Oh, sorry, it's 5 pi over 6. 5 pi over 6. So cos of 5 pi over 6, that one is, let's see, that's 150 degrees. So this is a 1, that's a -√3, this is a 2 because it's 150. So it's going to be -√3 over 2. So there we go. All right, I hope that helps a little bit.